Hello and welcome to our first experiment. We're going to be working on the second floor this year of the Atwood Chemistry Building. This room is very different than the one that you used for Chem 150 and 202 in that we have multiple fume hoods. Right now the camera's set up in the fume hood and I'm going to do the experiment in here. There's one fume hood for every 2 students. And go ahead and just kind of spin the video around and look around the room a little bit. You can see the hoods have multiple services. We've got air, vacuum, and water. There are drawers that contain equipment, shared equipment just like normal. And then around the room itself, there's several specialized pieces of equipment, including an infrared spectrophotometer in the back. We have balances, of course, and other things. And we'll get to many of those throughout the semester as we go. Today we're going to be looking, though, at doing some extractions, and specifically we're going to look at liquid-liquid extractions. And the idea here is that you have a mixture of 2 soluble materials, and you want to separate them. And so we're going to use their differences in solubilities to be able to separate the 2 from each other. Not only that, but we're going to manipulate those solubilities a little bit by using some acid-base chemistry. But the first question is just to look at our solvents. And so I have 3 solvents I'm going to look at here. I have deionized water. I've got methylene chloride or dichloromethane, same thing there. And I also have hexanes. And we'll be using the separatory funnel that I have set up here for our experiments a little bit later on. But first we're going to start just by looking at how these 2 solvents interact with each other. So we're going to head and start with our water. And let me go ahead and get a pipette here. Okay, and so I'm just going to put about 2 milliliters of water in here. Okay, water. Okay, then I'm going to add to this 2 milliliters of hexane. And so let's put our hexane in here. Okay, and I'll put it in so you can see it. All right, now hopefully you can see on the camera that we definitely have 2 different layers here. We've got a bottom layer and we have a top layer. The question that we ask, though, is which layer is which? Now you can use the densities to give you an idea of where to start. And the density is a really great way to look at it. The problem with density is that if you have enough of your solute dissolved in a particular layer, the densities can actually flip. So what we're going to do is I'm just going to take a couple of drops of water and we're just going to see where that water goes. Okay, now hopefully you can see as I do this on the camera that my drops of water are actually sinking through to the bottom. Okay, that tells me that water is on my bottom layer now. We can test that by also putting in a little bit of hexane. And so we'll do that, and up, it stays at the top layer. Okay? So in this case, it looks like our aqueous layer is the bottom layer. All right? Now, is that always the case? Well, it might be, but we want to go ahead and test that. So we're going to do this again. Let me put in my 2 milliliters of water. Okay? Then this time, instead of adding hexanes, we're going to put in our dichloromethane, CH2Cl2, and we're going to see what that does here. All right? So get about 2 mils of that, put it in here. All right, well, hopefully you probably saw a couple things happen at once. One is that we actually have 2 layers. Now, I actually have some bubbles in there, so it's a little hard to see the 2 layers. Let me see if we can mix that. There we go. Okay, so there's a boundary right here between the 2 layers. Now, as I poured it in, you probably noticed something. Whoa, got some evaporation happening there. So as I drop this in here, notice that the material I'm adding is sinking to the bottom. I'm getting a little layer there, but then it goes down. Okay, so dichloromethane is also an organic solvent, but it's denser than water. So in this case, the organic layer is on the bottom. So you have to be very careful with that. You can't always say that the aqueous layer is the bottom layer or the top layer because it depends upon what other solvent you're working with. Now the other thing we're going to do today is we're going to work with some 5% solutions of hydrochloric acid and of sodium hydroxide. And so just to make sure that that doesn't affect our solubility results, I'm going to run that really quick so we can make sure if we still see the 2 layers. Now, hexane is the primary organic solvent we're going to use today. So I'm going to try my hexanes with a 5% NaOH. Okay, so let me go ahead and put in my 2 milliliters of the hexanes. Now, if you remember last time, that was my top layer, but let's check. Okay, so sodium hydroxide, make sure I've got gloves on because sodium hydroxide is kind of nasty. Okay. And let's get this. This is 5%. about 1 molar. Okay, and let's go ahead and put that in there. Okay, so we definitely have 2 layers again, and I hope you can see that on camera. I'll check that a little bit later on, but there's a 2-layer line right there. And if hopefully you saw as I put it in that the NaOH was going to the bottom. Okay, so part of the way you can see that is you can see the bottom layer expanding as I put even more in. So with base, it doesn't seem to have affected that solubility. Okay, so we still find that hexane's the top layer, and we get 2 different layers. Now let's try that again with hydrochloric acid. This is also 5% hydrochloric acid. So we're going to put our hexane in here. All right, 2 milliliters of hexane. Okay, so we got our 2 mils of hexane there. And then let's put in our 5% hydrochloric acid. Down. And hopefully you can see the bottom layer starting to form there. I'll get out of the way in case that makes it a little easier to see. Okay. And once again, we'll confirm that it's the bottom layer by adding a little bit extra. Yep, we definitely have 2 layers, and the bottom layer there was the aqueous layer again. So we did that just to make sure that when we start using our acids and bases later on, that they don't affect which layer is which. Okay, that ends part 1.